I would never say anything bad about the other class while recording this. I didn't raise no fool. All right. For today, we're going to take a step away from talking about these trig ratios. They need to stay forefront up here. On your homework assignment that I'm going to give you that's going to be due on Friday, will be posted later today. This assignment will have a couple of these problems that are pulled, very similar from 1 through 24 from last night's assignment. I don't want these to be lost. This idea of the ability to transpose these trig ratios to finding more and more values is really helpful because it can take complex pieces that can be found from one simple thing. I can use sine to find all other 5. I can use tangent to find all other 5, which allows me to give more and more pieces of a single puzzle from one known piece of information. For today, we're going to review one concept and talk about one new concept. The review concept is a definition. It is called coterminal angles. All right. As a reminder from earlier this year, the idea of a coterminal angle goes back to the roots of this word. Co, indicating same. Terminal, indicating ending place. So, a coterminal angle has the same ending place on the unit circle specifically. So in this picture, these are the main angles of the unit circle, orientated between 0 and 360 if you're talking about degrees, between 0 and 2 pi if you're talking about radians. Now, a coterminal angle is an angle that would end in the same position. So, for example, ones we talked about in the past, a 30-degree angle, a 60-degree angle, a 90-degree angle. Each of these reference a place on the unit circle. However, they represent one possible name for that place. Because if I spin them far enough around the unit circle, I will eventually get back to 30, 60, 90, and every other number again. And if I spin farther, I'll get there again. And again. If I spin in the other direction, I will get there multiple times. The more times I spin, the more times I get to that same location. So example, 30 degrees has some coterminals, meaning angles that are the same location, just at a different number of spins. We found these by typically either adding or subtracting 360 degrees. So 30 degrees would have two coterminals that are next to it. It would have 390 degrees. This is the positive coterminal, meaning it's gone in the counterclockwise direction to the next available angle. So it starts at 30, does one full 360 degree spin, ends up back at 30, but because we've gone a full spin, it's actually at 390 degrees. I can also go in the other direction. So I start at 30, go clockwise this time. This is referred to as the negative coterminal. It ends up right back at 30, but it's found by subtracting 360. So it would be at negative 330 degrees. So if I talk about this very specific spot on my picture, this 30-degree angle, I could be talking about the natural 30. I could be talking about 390 degrees. Or I could be talking about negative 330 degrees. They're all the same thing. They all act the same. They're just in a slightly different orientation, but the same location. This matters a whole lot in a lot of design applications. A 30-degree angle versus a 390-degree angle, these are radically different things. Because for one has spun and the other hasn't. If you take a lawnmower blade, it may start at 30 degrees and after you've done the lawn, end at 30 degrees, but you hope it's spun somewhere along the way. So it's not actually going to end here, it's going to end at some reference angle, or what we call coterminal angle to it. So, for 30's coterminals would be ones like 390 or negative 330. And we could spin farther and get more coterminals. But for now, we're going to focus just on the first ones that are positive and negative around it. 60, same basic thing. We add or subtract 360. Meaning my coterminals would be things like 420 degrees and negative 300 degrees. So again, while 60 degrees is a very specific location on the unit circle, negative 300 degrees is that same location after a spin in the clockwise direction. Positive 420 is that exact same location just after a spin in the counterclockwise direction. So, every one of these angles has many, many, many coterminals to it, meaning different angles that act the same to it. For 90, we can find it the exact same way. For the ones that are in radians, there's a similar process, but instead of adding or subtracting 360, we add or subtract 2 pi. Because again, one full revolution in degrees is 360 degrees, but one full revolution in radians is 2 pi. So we come up here. Let's say I have something like pi over 4. Its coterminals are found by adding or subtracting 2 pi. Now, these can be a little tougher to do if you're not comfortable with fractional math. So one of the things we talked about was if you're not comfortable doing the fraction version, convert it to degrees using the pi over 180, and then convert it back after you've added 360 or subtracted 360 respectively. For this one, pi over 4 would become 9 pi over 4 if you were to add 2 pi to it. And we'd have to adjust the fraction to make it work. And if you were to subtract 2 pi, this would become negative 7 pi over 4. So in terms of the radian values on this particular picture, pi over 4, if I leave it in one circle, it's just pi over 4. If I go to pi over 4 and then spin one more circle, this is 9 pi over 4. If I spin the other way, going clockwise instead, negative 7 pi over 4. These are all coterminals, meaning they end up in the same location on the unit circle just after a set number of spins. And again, it can be found by adding and subtracting 360, which is a degree, or by adding and subtracting 2 pi if it's a radian. Now, those are great. Those are fantastic. A part of your homework, reviewing that idea, making sure you can find these coterminals. The other part involves our second and final topic on the day, a new topic, something that is specifically called a reference angle. Now, people always ask, like, what's the hardest part of certain math classes? Sometimes, I'm not going to lie to you, the math is hard. Like doing the physical application of the math, like being able to add and subtract these numbers, multiply and divide these numbers, take these equations and factor them, or use this fancy formula. That can be the hard part. In Trig, the math gets less hard. You have to know the terminology well for the math to be doable. If you mix up terms, you will often get wrong answers. Not because you're doing the wrong math, it's because you're doing the wrong problem. If I say, hey, I want a coterminal angle, it will have a wildly different answer than a reference angle, despite them sounding very similar. And when we look at them, they have similar ideas behind them. They reference a similarity between the two angles that is inherent. While coterminals are based upon after spins, they act the same after a certain number of spins. Reference angles are something else. They're based upon the reference to an axis, called the x-axis. Here we go. Second idea of the day. A reference angle. Now, the reference angle is defined as the distance of your angle to the x-axis. The distance from your angle to the x-axis. It sounds so simple. Or maybe you're looking at me going, no, Douglas, that don't sound simple at all. It's supposed to sound simple and it's supposed to be deceiving. But it actually is simple when you understand how this fits in. The idea is angles that are a certain distance from the axis act the same. Meaning a 30-degree angle acts the same as another angle that is also 30 degrees from the axis, even though it may have a different value. Examples. Up here. Your first four angles, their references are the angle. The reference angle for 30 is 30. The reference angle for 45 is 45. The reference angle for 60, it's 60. The reference angle for 90 is 90. Those cannot, do not, ever change.
So
Once we get past that number.
120 left to 60.
Yes, it does. So look at where 120 is. 120 is counting from here to there. That's 120 degrees. But that's the long way to get to the x-axis. The shorter way to get to the x-axis would be going down to the left. That is why 120 has a reference angle that is right here. And it is only 60 degrees. So as weird as it sounds, despite 120 and 60 being very different numbers, they will act the same because they are references. What will happen is it'll act predictably different, but the same. Meaning the values will take on very specific variations. Maybe one of the values will be a positive answer. That's the same as the other one. The other value might be a negative answer. That's the same as the other one, just negative. You can notice that on our pre-done unit circle over here. 120 degrees and 60 degrees. Notice the cosine value, the first value, positive 1/2 over here, negative 1/2 over there. The same value with a small adjustment to it. You can see how there's a balancing act in the unit circle. You can see it up here too. 60 and 120 are both 60 degrees away from the axis. This one has a half. That one has a negative 1/2 for its number. This one has a square root 3 over 2. That one has the same square root 3 over 2. Look at 135. Its reference for 135, it is 45 degrees away from the axis. And look how it references the same numbers that the 45 has, with a small variation. Well, 45 has square root 2 over 2 and square root 2 over 2, both positive. This one also has square root 2 over 2 and square root 2 over 2, but one's negative and one's positive. So it's the same values with a small twist to them. They're references of each other. The numbers are not changing, they're being modified. So the same values that exist on one side exist on the other. Look at 150. 150 is only 30 degrees away from the axis. But look at the 30-degree angle. Look at its values. The 30-degree angle over here has square root 3 over 2 in the first category, positive 1/2 in the second category. This one, the first one is a negative version, but it's the same numbers. Square root 3 over 2. The second number, positive 1/2. The same pieces, just has a small modification to them. So even though 150 and 30 are references, therefore different number values, their actual values are very similar. Take a look up here. A list of possible reference angles you could talk about. Reference angle for 30, that's 30. 60, that's 60. 90 is 90. As we get past 90, you start to see a reversal of this order. 120, becomes the same as 60. 150, the same as 30. 180, take a look at 180. It's on the axis. Notice it acts like 0. Over here, 180 has values of -1 and 0. 0 has values of 1 and 0. Same values, just in inverted form. The farther down we go, the bigger the difference becomes in terms of the number of values. But notice how the angles don't have any big differences. Look down here at 210. 210 is a very large angle, obviously. But it is only 30 degrees away from the axis. Right here, 30 degrees. Notice the numbers for 210. Right here, -√3/2, -1/2. It's only 30 away, so it's going to act like the other 30-degree angles. Just slight variations on them. So 210, despite being significantly bigger than both 150 and 30, still has properties that are similar to 150 and 30. They still have √3/2. It just may be an alternate version of it. Positive instead of negative, or negative instead of positive. The -1/2. Just a different version of the other two. This is how a reference angle works. So coterminals have the exact same properties. That'd be a comparison of the two. The first value is exactly the same for 30 as it is for 390. With reference angles, they are similar. They could be the same, or they could be a negative version of it. They could be both positives, like 1/2 and 1/2, or the negative version of it, -1/2. But it's still going to have a 1/2 in it. So, while there is an infinite list of angles that are coterminal, there's actually a pretty small list of references. Let's keep going. In reference, 210 acts like 30 degrees. 225 acts like 45 degrees. 240 acts like 60 degrees. 270 acts like 90 degrees. What you'll see is that every matching pair of angles always has these similar properties. They have these similar pieces that go together. So looking here, I can clearly see 225 is, again, 45 degrees away from the axis if we take the shortest path possible, and its values match every other reference angle of 45. So that means that at 135 it matches, because that's also a reference angle, and at 45 it matches. In fact, this setup works the same over here at 315. It has similar properties because they're reference angles. Reference angles have similar properties. Coterminals have the same properties. In geometry, we learn about the idea of congruency, which means the same, versus similarity, which means similar. In trig, this applies in the unit circle a lot. So again, in this picture, we have multiple components that fit the category of being in this set. It has to have that matching property. Coterminals match exactly. 330 degrees matches perfectly with -30 degrees because they are coterminal. They have the same angle. But 330 degrees matches similar to 30 degrees. Not the same, just similar. What that means is, in the bigger picture of things, because the unit circles are based upon the trig functions, the sine values will be similar. For 30, as for 330. The cosine values will be similar for 30 and for 330. Maybe one's positive, maybe one's negative, but they'll be similar. The tangent values will be similar. The cosecant, the secant, the cotangent will be similar. Some the same, some an inversion of them. Which means that if I know how 30, 45, 60, and 90 work, the references will tell me how all of them work. So, for homework tonight, a short list of problems. You'll be asked to identify 2 coterminal angles and a reference angle for each angle I give you. It's going to be a short homework time, 6 problems. Okay. But the idea is clearly distinguish between the two. Write down, the coterminals are these 2. The reference is this one. Now, as we discussed, the coterminals add and subtract 360 or add and subtract 2 pi. The reference always ends up back here in this top right corner. Every angle in this picture becomes either 0, 30, 45, 60, or 90. It's about how far away it is from the axis. So while 300 down here is a big number, its coterminals are found by adding 360 or subtracting 360. Its reference is only 60. Because 300 degrees is only 60 units away from this axis. Let's do a couple practices first. Without the unit circle in front of you. We'll do both parts. And I'll post a promise. The idea is you have to have these 2 separate in your brain. You have to be able to pull coterminals if needed, or pull references if needed. Let's take a look. Our first one. And you're welcome to try them on your own first. I'll give you a few seconds. Try them out. Let's look at the first one. Example. Here we go. Let's see. Classic 120 degrees. I want you to tell me 2 coterminals and the reference angle. There's only one. You can have a long list of coterminals, but there's only one reference. There can be only one Highlander. Now, as a reminder, to find the 2 coterminals, you need to either add or subtract 360. For the reference angle, this is a concept. It is the closest angle to the x-axis. I hope some of you kept track of that unit circle. If not, it is still in the Google Classroom, and it's still on Google. Might be helpful. Okay. Let's try them out. 120 degrees. 480 will be one of them. This is referred to as the positive coterminal because it's going counterclockwise, getting bigger. What would be the negative coterminal? Negative 240. Now, I didn't specify which ones to give me, but practicing getting both is a good idea. What's the reference? 60 degrees. Notice these are wildly different answers, but keep in mind, as we discussed in class today, these 2 will have the exact same properties. Everything about them the same. Every sine, every cosine, every tangent, all of them same. This will have a similar property. So it'll be very close. Maybe a half and negative a half. Maybe square root 2 over 2 and negative square root 2, 2. Or they could be the exact same, but they're going to be close. You can use one to help. This is your homework. This style of question. Be able to do both and keep them separate. because in a problem you'll have for Friday, I'm only going to ask for one. And you got to get it right. Another example before we go. I post the actual ones. Next example. What if I said negative 45 degrees? I want two coterminals and the reference angle. Two coterminals. And the reference. Again, coterminals are found by adding or subtracting 360. The reference is by the angle to the axis. It's the shortest angle to the x-axis. All right, hit me. Coterminals. I'll be honest, I use CTAs a lot in my homework and stuff for coterminal angles. I use CTA a lot.
315.
315?
And what, 405? Negative 405?
And negative 405. Other acceptable answers would be to add another 360. So having it be 675 would be another acceptable answer because it is another coterminal. Or going more negative would be another acceptable answer, going negative 765. What about the reference? 45. It is positive now. All right, I said one more. I lied. We're going to do one more because there's one thing we haven't done yet.
No.
No?
Say
No?
no, please don't.
Please don't?
Is there seriously gonna be one of these?
I would never.
There's probably gonna be two, like two, and two.
What is it?
Right?
Yep. 9.
5 or 3? 5 or 3? Two coterminals. And the reference angle. My cursive is improving, but not much.
Do you ever change it to radians?
Second?
Change it to radians?
Rarely. I mean, very rarely, but I will if I need to. If it's a nasty radian, I will. Otherwise, I rarely do. Okay. Remember, to do the radian version, instead of adding or subtracting 360, we can either add or subtract 2 pi, or you can convert this into degrees.
60 degrees, that's what I did.
60 degrees, and then you have to do the add or subtract, and then you got to convert it back. So that may mean you end up doing more work. But if it's easier work, I don't know about you, if I have to go outside and it means walking around the front of the building versus climbing over this wall, I know which one I'm going to do. If I want to do short, more work, or longer, easy work, I'm going to be like, easy work. Or maybe you're different. Maybe like, hard work. Let's go. For the reference, same concept. It is the distance away from the axis. Again, if you are struggling with the radian side of it, do it in degrees, but make sure your answer is in radians. So, coterminals. Give me one.
7 pi over 3.
7 pi over 3 is correct. Or 420 degrees. Okay?
Negative 5 pi over 3.
Negative 5 pi over 3 is the other one. 13 pi over 3 is another acceptable one. Negative 11 pi over 3 is another acceptable one. There's a lot. What about the reference?
60 degrees.
60 degrees? I can't accept 60 degrees, but I can accept pi over 3. In this case, the number and the reference are the same, which can happen. Alright. Your 6 problems will be posted in the Google Classroom, probably around lunchtime. They'll be pretty quick as we have them in class. You guys enjoy the rest of your day. We'll see how you do. 1, 2, 3, 4, 5, 6. Hey, Douglas.
Yeah.
Say how.
Me too.
And you got a word.
Thursday mornings anyways. Tuesday and what? Thursday.
Here's the homework.